AI/ML model, production planning and control. From a management perspective, the video for production planning and control provides a powerful, visual representation of workflows, resource allocation, and efficiency throughout the production process. Here's how management can interpret and leverage this tool. Pradeep K. Suri. Author, researcher, and AI/ML architect. Key insights for management. 1. Understanding workflow. Purpose: helps management visualize the entire production process, from supplier evaluation to customer feedback. Benefit: identifies the sequence of tasks, dependencies, and flow of resources. Action: use this understanding to streamline processes or eliminate redundancies. 2. Identifying bottlenecks. Purpose: the thickness of the links represents the magnitude of resources or outputs. Thinner links indicate inefficiencies or bottlenecks. Benefit: managers can pinpoint where production slows down and allocate resources to resolve issues. Action: reassess workflows in stages like inventory management, processing, or quality control. 3. Resource allocation. Purpose: shows the allocation of raw materials, workforce, and inventory. Benefit: ensures optimal use of resources and prevents overstocking or shortages. Action: improve inventory controls based on the flow of materials and order releases. 4. Monitoring quality and output. Purpose: stages like quality control and customer feedback highlight areas where production quality is tested and evaluated. Benefit: ensures the final product meets standards, reducing rework and customer complaints. Action: implement robust quality checkpoints and use feedback loops for continuous improvement. 5. Strategic planning and decision-making. Purpose: provides a high-level overview of the production pipeline, which supports planning for scaling production, automation, or outsourcing. Benefit: facilitates informed decision-making for short and long-term goals. Action: use data-driven insights to adjust strategies, like increasing automation in bottleneck stages. Additional management applications. 1. Performance metrics. Evaluate how each stage performs in terms of time, cost, and output. Compare actual performance against planned performance to identify deviations. 2. Cost analysis. Map stages with high resource consumption, such as raw material stock or processing, to optimize budgets and improve profitability. 3. Sustainability and waste reduction. The visualization can identify inefficiencies or excess in resource use, helping to create more sustainable practices. 4. Stakeholder communication. The diagram can effectively communicate production processes to stakeholders, such as investors, clients, or internal teams. 5. Scenario planning. Simulate how changes, example introducing a new technology or changing suppliers, affect the flow and output. Best practices for management. 1. Regular updates. Update the diagram with real-time data for accurate insights. 2. Integrate feedback. Incorporate feedback from teams working on the ground to refine processes. 3. Leverage technology. Use tools like ERP systems to automate data collection and visualize Sankey diagrams dynamically. By using the Sankey diagram effectively, management can enhance efficiency, optimize costs, and align production with strategic objectives, ensuring sustainable growth and market competitiveness. Project Management Professional, PMP, Certification. Understanding and utilizing tools like Sankey diagrams in production planning and control, PPC, can significantly support learning and practices aligned with the Project Management Professional, PMP, certification, especially in the following areas. How it relates to PMP certification. 1. Project Scope Management. PMP aspect emphasizes defining and managing all tasks required for project success. How it helps. A Sankey diagram visualizes each stage of production, aiding in understanding task dependencies and scope. It ensures all steps are accounted for, helping you avoid scope creep. 2. Project Schedule Management. PMP aspect focuses on creating and managing project timelines. How it helps. The diagram can highlight scheduling bottlenecks, dependencies, and inefficiencies, enabling managers to plan and adjust timelines effectively. 3. Project cost management. PMP aspect deals with budgeting and cost control. How it helps: the visualization identifies resource-heavy stages, example raw material stock, processing, which helps in tracking costs and optimizing budgets. 4. Project resource management. PMP aspect ensures efficient use of human, material, and equipment resources. How it helps: a Sankey diagram shows resource flow and allocation, enabling PMP professionals to optimize resource utilization and workforce planning. 5. Project quality management. PMP aspect focuses on maintaining the quality of deliverables. How it helps: quality-focused stages like quality control and customer feedback in the diagram ensure adherence to quality standards, which is central to PMP practices. 6. Project communication management. PMP aspect deals with ensuring effective communication among stakeholders. How it helps: Sankey diagrams are excellent for presenting complex workflows to stakeholders visually, facilitating clear communication about processes and issues. 7. Risk management. PMP aspect identifying, analyzing, and responding to project risks. How it helps: bottlenecks or inefficiencies in the diagram signal potential risks, example delays in material stock or production, allowing for proactive risk mitigation. 8. Stakeholder engagement. PMP aspect focuses on managing stakeholder expectations and involvement. How it helps: Sankey diagrams can be shared with stakeholders to demonstrate transparency in production flow and to gather feedback for improvements. Practical application for PMP. 1. Scenario-based learning. In PMP exam case studies, you need to visualize workflows or solve bottlenecks. Tools like Sankey diagrams can provide a structured thought process. 2. Tools and techniques. PMP encourages using visualization tools under data representation techniques, BOK. A Sankey diagram qualifies as such, showcasing your ability to manage data effectively. 3. Enhanced decision-making. PMP emphasizes informed decision-making, which is supported by visualizations that clarify workflows, resource allocations, and potential risks. 4. Presentation skills. Presenting such diagrams during project reviews or meetings aligns with PMP's focus on communication and stakeholder engagement. How to incorporate in PMP preparation. 1. Learn visual tools. Familiarize yourself with visual management techniques like Sankey, Gantt charts, and flow diagrams. 2. Case studies. Practice applying Sankey diagrams in production-related PMP case studies. 3. Practical projects. Use Sankey diagrams in mock projects to simulate real-world challenges. By integrating Sankey diagrams into your workflow analysis and decision-making processes, you can demonstrate a higher level of competency in project management principles, helping you excel in both PMP certification preparation and practical project roles. To generate reports and graphs for top management, middle management, and operation level, the Python program can be structured to cater to their respective needs and perspectives. Here's how the stages, reports, and graphs can be tailored for each management level. 1. Top management. Focus, high-level overview, KPIs, strategic decisions. Key metrics. Total production output vs target. Bottlenecks in major stages. Cost breakdown and budget adherence. Customer feedback and quality metrics. Graphical representation. Sankey diagram, for overall workflow visualization. Bar chart, production stages with cost and time metrics. Pie chart, cost distribution across stages. Line chart, trends in production output and quality over time. Report features. Summary of key metrics, example total costs, time spent. High-level insights on efficiency and profitability. 2. Middle management. Focus, process efficiency, resource utilization, resolving bottlenecks. Key metrics. Stage-wise resource allocation and usage. Detailed bottleneck analysis. Inventory vs raw material requirements. Stage-wise quality control results. Graphical representation. Stacked bar chart, Resource allocation across stages. Gantt chart, detailed timelines for stages. Heat map, areas of inefficiency or delays. Scatter plot, stage performance vs resource input. Report features. Stage-specific breakdowns, time, cost, resource. Insights into process improvements. Recommendations for reallocating resources. 3 Operational level. Focus, daily tasks, execution, and immediate issues. Key metrics. Real-time production status. Task-wise completion and pending activities. Immediate supply and demand gaps. Quality check rejections and fixes. Graphical representation. Progress bar, task-wise completion percentage. Timeline chart, real-time status updates. Bubble chart, QC issues by severity and frequency. Area chart, cumulative production progress. Report features. Detailed task list with priorities. Specific QC issues and resolutions. Recommendations for immediate action. The process flow diagram created by Pradeep K. Suri, illustrating the key stages involved in production planning and control. Here's an in-depth explanation of each component. 1. Supplier evaluation. Purpose, to assess and select suppliers who can provide quality raw materials. Activities, evaluating supplier performance, quality of materials, and reliability. 2. Raw material stock. Purpose, to manage the inventory of raw materials required for production. Activities, stocking sufficient quantities, tracking stock levels, and replenishing as needed. 3. Release purchase order. Purpose, to formally request the purchase of raw materials from suppliers. Activities, issuing purchase orders, confirming orders, and scheduling deliveries. 4. Raw materials. Purpose, to receive and store raw materials for production. Activities, inspecting deliveries, storing materials in inventory, and managing stock levels. 5. Planning. Purpose, to plan the production process based on demand and resource availability. Activities, creating production plans, scheduling tasks, and allocating resources. 6. Scheduling. Purpose, to create a detailed timeline for production activities. Activities, setting production schedules, assigning tasks, and managing deadlines. 7. Inventory management. Purpose, to manage the inventory of finished goods and raw materials. Activities, tracking inventory levels, managing stock, and ensuring availability. 8. Production. Purpose, to execute the manufacturing process. Activities, converting raw materials into finished products, following production plans, and meeting quality standards. 9. Processing. Purpose, to process the finished products for final quality checks. Activities, conducting inspections, applying final touches, and preparing products for packaging. 10. Quality control. Purpose, to ensure the products meet quality standards. Activities, testing products, identifying defects, and implementing corrective actions. 11. Shipping. Purpose, to deliver the finished products to customers or distribution centers. Activities, packaging products, arranging shipments, and managing logistics. 12. Workforce allocation. Purpose, to allocate and manage human resources for various production tasks. Activities, assigning tasks to workers, managing schedules, and ensuring workforce efficiency. 13. Packaging. Purpose, to pack the finished products for safe transportation. Activities, packaging products, labeling, and preparing for shipment. 14. Customer feedback. Purpose, to collect and analyze feedback from customers. Activities, gathering feedback, assessing customer satisfaction, and making improvements. Summary. This comprehensive process flow diagram visually represents the interconnected stages of production planning and control, highlighting the importance of each stage and how they contribute to an efficient production process. It helps in understanding the flow of materials and information, ensuring a smooth and effective production cycle. Top management sample report and graph from the shop floor. Total production output vs target. Explanation of the bar chart, Total Production Output versus Target, Monthly. The bar chart titled Total Production Output versus Target, Monthly, by Pradeep K. Suri compares the target production output to the actual production output over a span of 6 months, January to June. Key components. X-axis, months represents the months from January to June. Y-axis, units produced measures the units produced, ranging from 0 to 1,400 units. Bars. Blue bars, represent the target output for each month. Green bars, represent the actual output for each month. Dashed lines. Red dashed line, represents the average target output across all months. Purple dashed line, represents the average actual output across all months. Observations. 1 January. Target output, higher than actual output. Actual output, lower than the target. 2 February. Target output, slightly higher than actual output. Actual output, close to the target but not quite reaching it. 3 March. Target output, higher than actual output. Actual output, below the target. 4 April. Target output, actual output exceeds the target. Actual output, higher than the target. 5. Target output, slightly higher than actual output. Actual output, close to the target, but slightly below. 6 June. Target output, actual output is slightly lower than the target. Actual output, slightly under the target. Summary. The bar chart visually demonstrates the performance of production against set targets over 6 months. April stands out as the only month where actual output exceeded the target. For the other months, the target output was consistently higher than the actual output, though the differences varied in magnitude. The average lines, red for target and purple for actual, provide a quick reference to see overall trends and performance. This detailed visualization helps in understanding how well production targets were met over time, highlighting areas of improvement and success. The image is a stacked bar chart titled Actual vs Target Production Output, %, created by Pradeep K. Suri. It compares the actual production output percentages to the target production output percentages for each month from January to June. Here's a detailed explanation. Key components. 1 X-axis, months. Represents the months, January, February, March, April, and June. 2 Y-axis, percentage. Measures the production output as a percentage, ranging from 0% to 100%. 3 stacked bars. Each month has a stacked bar divided into 2 sections. Bottom section, blue represents the target production percentage. Top section, green represents the actual production percentage. Monthly breakdown. January. Actual output, 48.72%. Target output, 51.28%. February. Actual output, 48.94%. Target output, 51.06%. March. Actual output, 49.54%. Target output, 50.46%. April. Actual output, 49.02%. Target output, 50.98%. Actual output, 48.98%. Target output, 51.02%. June. Actual output, 49.09%. Target output, 50.91%. Interpretation. The stacked bar chart visually compares the actual production outputs to the target production outputs for each month. Actual output versus target output. For each month, the actual production output is slightly lower than the target output. This consistent pattern shows that while the production goals are almost met, there is a small gap that could be addressed for improvement. Percentage breakdown. The chart helps in understanding how close the actual production is to the target, with the percentages showing the minor differences. Summary. This chart provides a clear and concise comparison between actual and target production outputs monthly. It highlights how the production team performs relative to their goals, identifying areas where there is a slight shortfall in meeting targets. This can help in making informed decisions for process improvements and resource allocation to bridge the gap and achieve desired production levels. Thank you.